Have your first quiz from chapter 5 coming up due tomorrow. And it covers the stuff on this worksheet as well as a little bit of the stuff that we'll talk about for the second half of today. So make sure you get that done. And then I think we'll wrap up chapter 5 this week. So most people are pretty familiar with decimals. With the worksheet from yesterday, the first one I was looking at was an example of converting decimals back into fractions. So if you're trying to go decimals to fractions, okay, the first one I put there, so 0.35. So you always go to the end of the decimal and find out basically what's the last place value. So in this case, this is in which spot? Right, so that's the hundredth spot. So then this would translate to a fraction of 35 hundredths. But with fractions, we always want to reduce them. So then we would reduce that one because these are both divisible by 5. And so we just go down. So you go, 35 divided by 5 is 7. 100 divided by 5 is 20. And so that would be your solution to the first one. And so then you can always check it, right? Because you can take 7 and go 7 divided by 20, and you can make sure that it comes back to 0.35, but it will. So you can always check them in your calculator. Yeah? Okay, so if you get a whole number involved, then if you're trying to turn that back into a fraction, typically I just go to mixed number notation because I know the 2 is not going to change. It's going to stay at 2. This is a whole number. So then I just worry about my decimal portion. And again, our decimal portion here ends in the hundredths. And so this would be like 2 and 34 hundredths. All right, but then that's reducible because 34 and 100 are both divisible at least by 2. So we could take it down. 34 divided by 2 is 17. 100 divided by 2 is 50. So we get down to there. And I think you're done because I think 17 is prime, and 50 is definitely not divisible by 17. So that'd be the answer for that one. You could convert it back into an improper if you wanted, right? Because 50 times 2 is 100. Plus 17, so you could technically also write this one as 117 over 50 if you wanted. They're both the same. Okay. And then the last one, even if there's zeros in there, same strategy. You just figure out where it ends. So that third one ends in the thousandths, and so then this is going to be 15 in the thousandths place. So 15 thousandths. And then that one, again, is reducible by 5. So 15 divided by 5 is 3. 1,000 divided by 5 is 200. And so it'd be like 3 out of 200. And you could check all these. Try 3 divided by 200, you should get 0.015. Try 17 divided by 50, you should get 0.34. Okay. Any questions on those three, going from the decimal back to the fraction? Seems okay? All right. Then going the other way is a little bit easier because you just have to pull out your calculator. So fraction to decimal. I told round to the nearest thousandths if necessary, but it's not always necessary. So 13 over 20, that's just literally 13 divided by 20. So we just pull out our calculators. We go 13 divided by 20, and it comes out to be what? 0.65. Boom. 5/9 is one of those that doesn't translate that nicely because if you take 5 and you divide by 9, it's 0.5555 ... right? Okay, so I asked you to round to the nearest thousandths, so that's how many decimal places? Thousandths is 3 decimal places, yeah? And so you just go next door. Next door there's a 5, which tells you that 5 should be rounded, what? Up to 6. And then you drop, technically that's an approximation now. Then you drop the decimals beyond it. All right. Okay. And then we have this negative 284 over 25. So you just pull out your calculator and you say, it's 284 divided by 25. The negative we can just apply at the end. So if you divide 284 by 25, what do you get? This is 11.36. That one you don't even need to round, I don't think, right? Yeah, it just comes out evenly, so don't lose your sign, though. All right. Any questions? Yeah. Was there a question or you just stretching? Cool. No, you're good. All right. Everybody good with that? The question's there. Okay, cool. So that's how you convert in between the two forms. Sometimes it's advantageous to go decimals. Sometimes it's advantageous to stay as fractions. I showed you, we saw an example of that yesterday where like sometimes going to decimals you can get in trouble because you might round too liberally or round too much in the intermediate. So then working with decimals and fractions together was the next couple examples I gave you there. So the first one I said was, okay, so let's say 18 divided by, 0.75 plus 0.15. Order of operation tells us we should do what here first? Division or addition here? Addition should happen first because it's inside the parentheses. So then the 18 will stay there. And then 0.75 plus 0.15 was 0.9. All right. And then at that point, I just, you just pull out your calculator. Just go 19 divided by 0.9. What does that give us? 20? Yeah. It's 20 even. This is another one of those situations like we saw, I don't know, maybe a couple weeks ago. You take 18 and you divide it by a number and it actually gets bigger. Why does it get bigger? It gets bigger because the number you were dividing into it was less than 1. Right? So you can't come out with the bigger numbers we divide. All right. Then what we got here, this was 75.42. We're talking dollars here. Plus 0.18 times 75.42. And then divide by 5. Okay, so order of operations, so you go within the parentheses. What comes first inside there? You want to go there, right? So you need to do your multiplication within there first. What does that come out to be if we take 0.18 times 75.42? What do you get? Nobody has a calculator today? I'm trying to simplify that right there. What does that come out to be? This is 1358. Okay. So that's 1358. Well, so that's the thing. So is there more stuff there? Is there more beyond the 8? There should be, right? What's beyond it? A 1, is that it? Aren't there 2 decimal places beyond it? There should be more. Is it 1.6? It's 13.5756. 5756. So this is the thing. If you're going to, this is what we were talking about yesterday, is that you don't want to round too soon. Okay? Because you can round there, but then what's going to happen is that when it gets carried through calculations, what you risk is if you round in the intermediate steps before the end, what you risk is that rounding error might get worse as you go, and it'll mess up your answer. So when you're dealing with decimals, you always want to keep as many decimals as you can until you finish, and then you can round to the very end. So this would become 75.42. If you add these two numbers together, what do you get? It's like 80, what does it come out to be? 88.9956. And then I still wouldn't divide at that point. I would wait. So then divide by 5, and then what does that come out to be? 117 or 107? 17.79912. Okay. Now, in this case, if you look at the problem, everything was in here in dollars. So let's go ahead, and if we were going to round to the nearest cent. Okay, well, where is the cents? Right there. Okay. Well, what happens when you round to the nearest cent? Well, I got to round that 9, but if I go next door, what's going to happen to that 9? It's going to round up to a 10, so what happens? It's going to carry over into the column in front of it, right? So it's like the 9 rounds up to a 10, but there's no room there, so we have to carry it over, and this will actually become 1780. So rounding early might not have screwed you up on this one, actually. But this is one of the examples. So if you have a 9 that rounds up, it's going to carry over into the place value in front of it. And so just be 1780. Questions on that one? All right. How about the fourth one? It says that Maria got paid $362.50 for 25 hours. So what's her hourly rate? How do you solve for that? Yeah, it's a division problem. Okay, so you need to take 362.50 and you need to divide by 25. What do you get? 1450. Okay, what's the units there? Dollars. There's more though. Yeah, it's the unit would be dollars per hour, right? So this is something we're going to look more at this later in the course. I don't think we looked at. No, we haven't looked at unit rates yet. This is something called a unit rate, but actually it's because what happens is what you're doing is you're dividing a dollar amount by an hour amount. Okay, and so the two different things that you're messing with have two different units, and so you can do you do the operation to get the number value out of it, but you also pay attention to what the units are based on the operations, and it's dollars over hours, right? So it's dollars per hour. That's how you come up with the unit. All right. Cool. Over here, everything was, adding dollars, so everything just came out in dollars. I showed you yesterday, how do you decide if I'm trying to compare values? Like, so if I'm trying to compare 0.92 to 7/8, what would be the easiest way to do that? Yeah, turn this 7/8 into a decimal. And if you turn 7/8 into a decimal, what do you get? Is it 875? 875. So then you can decide, well, which one's obviously bigger? Not 7/8, right? So you convert that into decimal to help you out. So then the other one I gave you, this was negative 0.44, and I wanted you to compare it to negative 9/20. So if you turn negative 9/20, what does that become? It becomes negative 0.45. Now the question is, which one of those is bigger? Yeah, this one is bigger, right? Why is 0.44 bigger than 0.45? Because we're on the negative side, right? Inequalities just measure which one's further along on the number line. So negative 0.44 is actually to the right of negative 0.45, so it's a little bit bigger, right? Perfect. Any questions on these examples so far? Where the numbers came from? Right? So then the next one I showed you yesterday, there were applications of circles. Whoops, that's not what I wanted to do. Come on now. Go here. So for circles, there was two formulas I gave you. So you need to know that these formulas, you need to know these ones. Like you have to memorize them. So you need to know this. The two formulas I give you for circles, and the formulas I gave you were that if you want to calculate the area of a circle, it's pi times the radius squared, and if you want to calculate the circumference of a circle, the circumference is pi times the diameter, right? And then we know, so what we were talking about yesterday, we'll just use the approximation of pi, which is 3.14. R stands for radius, and D stands for diameter. All right, and then I drew you the picture yesterday, right? If you know the radius, you can always calculate the diameter, because the diameter is twice the size of the radius, right? A radius is like a half diameter. So then the example I gave you on the worksheet yesterday, I said, let's say that you have a tabletop at a coffee shop, and the diameter is 2.5 feet. Okay, so that's our diameter. What would be our radius of that circle if we're given the diameter? Yeah, you got to cut it in half. So it depends on what you get. So if you know the diameter, you can always find the radius by cutting it in half, or vice versa. So if I gave you the radius, you could just double it, and that would give you the diameter. And you need them both based on the formula. So I asked you to calculate the area and the circumference. So if we were going to calculate the area of this circle, so I'll write down my formula. It's always pi times r squared. So in place of pi, I would put my 3.14. For the radius, I use the 1.25. That's going to get squared. So order of operations says exponents times before multiplication. So then we need to solve here. So what is 1.25 squared if you put it in your calculator? 1.5625. Okay. Because what does the exponent tell you to do? This is telling you to multiply the number by itself 2 times. It's not times 2. It's the number by itself 2 times. Okay. All right. So then now we can just multiply those two values together. If you go 3.14 times 1.5625, what does that come out to be? 4. Just give me all the decimals. I don't know what it comes out to be. There's a lot of them. 625. Stop. Okay. What are the? You could round it. So say if I want to round in the nearest hundredths, we could say okay, that's about 4.91. What's the units here? Because the diameter was in feet. Yeah, and it's feet squared, right? Because it's always square units for area. Okay. So you have feet squared, or square feet. So it's a little under 5 square feet. The circumference is a little bit easier calculation because you don't have to square anything. So for the circumference is always pi times the diameter. So we'll plug in 3.14 for pi, and we'll plug in the diameter was 2.5. So then you just multiply those out, whatever that comes out to be. What does that come out to be? 7.85. And then what's the units here? Just feet. Circumference is a perimeter. It's a distance. And so the units on a distance are just the units. So you only have to worry about feet squared if you're talking about area. All right. Perfect. Any questions on those two? Just make sure, so these right here, these formulas right here, make sure that you have these. If you don't already, make sure you have these memorized. And there's questions like this on the quiz as well, so you'll have a chance to use them. So. All right. Then the last one we covered, it says a computer's on sale. So it's on sale for 2/3 of the original price. And the original price was $449.99. Okay, and I want you to round your answer to the nearest cent. What is the new price? So, how do you calculate a fraction of a number? Yeah, so the of is a keyword. It means multiplication. So if you want to calculate a fraction of a number, you need to go 449.99 times 2/3. Now, there's 2 ways to do this. You could do it the converting to decimal route, or you can remember what I showed you yesterday, is that when you're multiplying a fraction by a number, it just gets multiplied by the numerator. So we can just multiply 449.99 times 2, and then divide it by 3. Then we don't have to worry at all about rounding. So if you take 449.99 times 2, then that gets you what? 999. Is it 999? 98? Okay. Wait, isn't it 890? It should be, I think it should be 899.98. Am I wrong?
899.98.
I think it should be 899.98. Okay. So first you can multiply by the 2, then you can divide by the 3. And then if you divide that by 3, what do you get? Yeah, it's just 299.99333. The 3's will go forever. And then if we're rounding the nearest cent, so there's the cents, the hundredths, so you just go next door. Okay, 3 tells you to do what with that 9? Leave it alone, yeah. Just leave it at 9. And then that would be your answer. Okay. You can get the same answer by going alternately just going into decimal form. So you could do 2/3 and turn it into a decimal. Excuse me. What's going to happen though is it's going to be a decimal that never ends. But for the sake of rounding, for the sake of working with it, you have to round it somewhere, which is fine. It's just that you want to make sure that if you're going to go to decimal form, keep a bunch of decimal places before, just make sure you go out a really long ways.
Can you just leave it in your calculator?
Yeah, and if your calculator will store it too. That's the thing. Yeah. Yeah, if in your calculator, you could just, if from your calculator, you could just get that number. It'll store it, and then you can do the multiplication. Yeah. If you have to round it, just make sure you keep enough. But your calculator will basically tell you the exact same thing if you store it, which, just round. So it'll be the same basic thing. Yeah? So either way, round it or send it to a decimal first and then work with it. Just make sure you don't round early on. Or you can just multiply by 2 and then divide by 3. It'll work both ways. Yeah? Okay. Perfect. So today, what I wanted to do, there's 2 more applications of decimals I want to talk about, and then I'm going to give you some practice problems. This one I was thinking about collecting. It has some equations on it for you to practice with. I don't know if we'll have time to do it today. I might collect it tomorrow, but anyways, the other applications I wanted to look at is the you'll run into decimals when you're calculating like means and medians. Okay. So the mean and the median of a data set, what these do is these are measures of the center of a data set. So a lot of you guys will probably end up taking statistics. And so I teach statistics every quarter pretty much. And one of the things we do a lot in statistics is we do data analysis, like taking data and trying to get information out of it. So one of the things that you're often interested in when you're analyzing data is, where is the center of this data set? And the mean and the median are ways to get you. It's like you don't want to have to look through like 40 numbers. The mean and the median are a way to take a bunch of data and consolidate it into one number that tells you something about the big group. Okay. I'm guessing you've probably calculated means or medians at some point in your life. So the mean is just another name for what? It's another name for the average. Okay. So and to calculate an average, what do? You just take up all of the numbers, right? And then you divide by how many? Yeah, so you just sum of all the values, and then you divide by the number of values. Right? So if you had 10 things, you divide by 10. We'll do an example of this, right? So the mean is, you add everything up, and then you divide it by how many observations or however many values you have. The median is like the middle value in the sense that the median you don't get the median by adding things up or anything. The way that the median works is it's a 2-step process, is you have to order your values from least to greatest. So first of all, you just order all your data. And then what you do is you pick the middle value. That's going to be your median. But what happens is, okay, if there's an odd number of values, all right, then you just pick the middle one. But sometimes you won't actually have a true middle, because if there's an even number of values, then you have to average the two middles. Okay. I'll show you an example of both those in a second. All right, so I'll let you finish writing that down if you are. And then we'll collect some data. And they both kind of measure two different things. We're not going to spend as much time talking about the difference between the mean and the median and how they vary. But at least this way you'll see them. You'll know how to calculate them. You probably will use them in Math 50. You go to Math 50. And then we definitely use these in stats, which is Math 146. All right, so let's do. We can collect our own data here. So let's do an example. I want room though. So okay, so let's say we looked at our commute times. So what I'd like to do is we'll just go around the room, and then just to the nearest minute, tell me about how long it takes you to get from wherever you start in the morning to CBC, right? So then we'll just have a whole bunch of data. So we could start in the front here. So we'll just go through. So like, how many minutes does it take you to get to CBC in the morning?
25?
Yeah, it can be an estimate. Obviously, it varies every day, but we'll say,
About 40 to 85.
40. Yeah, okay, that's fine.
About 40 because I take the bus.
Yeah, 40. Okay, and then we'll go back here. So how many?
25.
About 25. Yeah,
Like 12 minutes.
12. All right,
45.
about 45. Yeah, and then we'll pass. We'll just go row by row, or it doesn't matter. How long is your commute?
10.
10. Nice. No power.
20.
20.
15.
15.
20.
20. Yeah.
8.
8. Nice.
15.
15. Okay, going back, Liam, what's your commute time? 10. And then moving over to Chan? 10. Go back?
40.
About 40. Okay. Then 20. Okay. All right, and then 45. Okay. 13. Okay. 11. There you go. All right, so you have a whole bunch of commute times. So first off, you just kind of observe, okay, so how many people were in our data set? So it's 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, 14, 15, 16, 17, 18, 19 people in our data set. Okay, in this particular set. All right. So then, if we wanted to calculate the mean, okay, so to get the mean from this, all we'd have to do is we just have to add all those up. I'm just going to do a dot, dot, dot because I don't want to write them all. And then we're going to divide by 19. All right. So let's try that out. People with calculators. Add those up. I'll try it too, and we'll see if we can come up with the same answer than the average. Curious what you guys get when you add them up. 414? Okay, for some reason I got 424. Maybe you missed a 10. 424? 424?
Yeah.
425. I'm getting lots of 424s. Okay, so my guess is maybe you only put one of those 10s in or something. So that'd be 424 when you add them all up. And then you just turn around and then you divide them by 19. And then what do you get? 22 point, say 3. We'll round to the nearest tenth. Right? So, be approximately, technically. Yeah? So just add them all up, you divide. And the average, it gives you kind of a sense of how long people commute overall. You know, on average, we commute 22.3 minutes as the students in this class. Now, the mean's the easier one probably. The median takes a little more work because if we were going to go do the median, we have a first step, which is what do we need to do with our data? Yeah, we need to order all this stuff. Okay, so now we need to go put them in order from, say, least to greatest. So if we go through and then we start ordering them, where are we at? We got 8. Then what's next? Then we got 10. And 10 pops up how many times? 1, 2, 3 times. So 3 people have a commute time of 10 minutes. Then what's next? Is there an 11 up there? Just one. Someone said 12. Someone said 13. What else? 2 15s were next. There's a 15 here and a 15 there. Okay. Any more than that on 15? Okay. Then what? 3 20s. All right. We're next. Nothing between there. 3 20s. 2 25s. All right. And then what came next? 3 40s. Nothing between 25 and 40. It's like all or nothing. 40, 40, 40. And then a 45. We can check just to make sure. Probably should count up your numbers to make sure you didn't miss anything. So I'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We missed someone. Was there 2 45s? 2 45s. Yeah, that'll be our 19th person. Right. So then in this case, I was telling you it matters whether or not you have an odd number of people or an even number of people. Since we have an odd number of people, there is a number directly in the middle, right? Because if you're talking about 19 and you start working your way in, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's a number that sits directly in the center, right? Where there's 9 above and 9 below. So in this case, we would say that the median would be 20 minutes. So there actually is a median. All right? Does that make sense? So that's how you calculate a median. You order your data up and you pick the center. Any questions about calculating medians or like how I got these numbers, how to do it? Is there anyone here who's like never seen means or medians before, like ever? Most people I think have seen them. Yeah. All right. The only special kind of circumstance that you have is like, let's say that I'm gonna. Oh, I did not want to do that. Oh, well, you guys have the data. Okay, but let's say that if you throw in just to see what it looks like with an even number. So let's say if you like throw in mine. So my commute time is usually about 18 minutes. Okay, so if I throw in an 18-minute commute time, just read me the numbers in order for me real quick since we already got them down. And I'm just going to recopy them down. Will someone do that for me?
8.
Okay, 8. 10 3 times. Right, and then what was it?
11,
Uh-huh.
12, 13, 15, 15, 20, 20, 20.
So then I'd be stuck right here. I'd get inserted right there, right, between 15 and then how many 20s were there?
3,
20, 20, 20,
25, 25, 40, 40, 45,
40, 45, 45. All right, so did we get them all? 1.
40s.
3 40s? Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 17, 18, 19, 20. So now what happens is that if you throw me in, now we have 20 people. Okay, and so if you try to split the data in half, it doesn't work that well, because if you split it, there's 10 above and there's 10 below. And so there is no number directly in the middle. So how do you pick? So you don't want to pick just one or the other because these numbers happen to be pretty close, but they might not in some data sets. And so that's why what we do is we take those two numbers and we average them, which, in other words, we find the mean of those two numbers. So you add them up and you divide by 2. And so in this case, we would say that the median would be 19 minutes. So you just average them. So even though 19 is not one of the observations in our data set, it's the average of the middle two. And so that would be the answer for that one. All right. So if there is a middle number, then pick it. If not, just average those middle two. All right. So I'm going to keep that data up. And I want to, the other thing that chapter 5 goes into is it talks briefly about probability. Okay. So then, like, my question would be something like, let's say if you pick someone in this room, just, out of a hat. So let's say I'm just randomly picking names. Okay. Then I'd like to know, well, what is the probability, or what are the chances? So probability is kind of another way of saying the chances that you end up picking a person with a 20-minute commute. All right. So the mean and the median, they measure center. Probability measures how likely something is to occur. All right. So it's like if I just throw everyone's name into a hat, and I just pick someone's name out of the hat, and I say, hey, well, how long does it take you to get to school? What's the probability that the person I talk to has a 20-minute commute? Right? So how many people in our class have that?
19 or 3.
Yeah, so then what we have is, so we'll just use this data set that's up here. Let's say that I'm in the pot there. So there's 3 people that have a 20-minute commute out of how many people sitting in the room right now? And if you count me, it's up to it increases up to 20, right? So then the answer would be, it's 3 out of 20. But as a fraction, that would be 3 out of 20. Okay. So probabilities can be written as fractions, or you can write them as decimals, right? Because we know how to convert fractions to decimals. So it'd be 0.15. So you could think of it as a 3 and 20 stance, or as a decimal. So that probabilities have at least 2 forms. There's the fraction form, and there's the decimal form. And actually, you could also convert that into percentages, because that's what we're going to do next in Chapter 6, because this is the same as what percentage, if you remember percentages very well. And we'll talk about that more in the next chapter, but you could also think of it as a 15% chance. But we haven't really gotten into that too much. So the fraction is fine. Okay? So probabilities make a nice application of fractions and decimals because they can be displayed both ways. And so in general, if you're going to calculate the probability, so if you're calculating the probability of an event, it's a fraction. Okay? It's a fraction where you look at, the number of ways the event can occur, like how many people have that attribute, and you divide by the number of total possibilities. So, the classic example was like if you're looking at like a bag of M&Ms or something. And let's say in a bag of M&Ms there's let's say there's 10 blue, maybe 8 green, maybe 8, I don't even remember the colors, yellow. There's blue, green, yellow. There's red, right? Yeah. Let's say 6 red and 5 yellow. Already did yellow. It's brown. Brown's the other one, huh? Okay. So then let's say if you pick, let's say if you go in and you pick 1 M&M, what's the probability that you get a, say, green? Okay, well, first off, you need to figure out what? Yeah, it's going to be a fraction, but first we need to figure out the total. So the total number of candies in there is what? 37. Okay, so that's your denominator because that's how many things you have to pick from. And then how many have what you're looking for? Be 8, right? So as a fraction, it would be an 8 in 37 chance. Or if you were going to write that as a decimal, what would that come out to be? 8 divided by 37? 216, say. If you round, is that right? Or is that rounded wrong? Or did I round that wrong? Yeah, that's right. So it's about 0.2. So that would be the decimal form. Or, like we're going to start talking about in the next chapter, you could think of that as a percentage. It's like a 21.6% chance. So, all right? Questions? You don't have to worry about the percentage right now. But all right, so the point is there's fractions, there's decimals. You can convert between the two. You can work with both, and they both have a lot of applications. And probability, means, and medians, that's one of the ways where we encounter fractions and decimals a lot. So that's what we got going on for Chapter 5. I think there might be a little bit more we'll do tomorrow, but that's as far as I got for today's worksheet. So I don't know if you'll have time to finish it in class, but you could try. But this one I actually want to collect and grade. This one has a couple equations on it with decimals. I didn't do any examples. And when I say I'll grade it, I mean like I'll grade it, I'll give you